Thank you. Thank you, and good afternoon. Thanks for having me. I'm going to be talking today about scaling Python interactive applications with Jupyter. My name is Luciano Resende. I work at IBM at a CODE group, which is Center for Open Source Data and AI Technologies. If you guys need to ask questions later on or reach out to me, here are my information, so feel free to contact. I'm just going to go over a couple of slides. Basically, when I talk about IBM, I think a lot of people think that we do a lot of proprietary software, and we are actually contributing a lot to open source software. We do over 100K commits per month. We consume in most of our products. We also have a lot of learning and connect with the communities to teach others how to utilize and contribute to the projects that we are working on. IBM generates a lot of open source projects. Projects that are coming from research, for example, they go into a place that we have on GitHub at IBM organization. Those projects then maybe get graduated to foundations where we want to get open governance from those. We do a lot of the things around communities that we contribute. These are some of the communities that we are focusing or strategically focusing on those, but we do a lot more than only that. We also have open source the documentation and materials that we use internally for helping other IBMers contribute. So if your company or your organization is trying to go open source or trying to contribute to open source, there are lots of things that are available on our website as well. As for the group that I work on, CODE, Center for Open Source Data and AI Technologies, is a group that do 100% of the contributions into open source. So all the things that we do here is on the open source. We work directly with the community. So for data, we work with Spark and related projects. AI, we contribute to TensorFlow and others. We also do AI platforms such as Fiddle, which is Fabric for Deep Learning, and also a lot of contributions into the Jupyter organization. So what is Jupyter Notebooks? I think a lot of you guys were here in the morning and attended the tutorial that we were using Collab. So that's an example of a notebook environment where you have interactive development happening. But really, when you talk about notebooks, it's the ability to start putting together a source code, but also being able to interactively execute, get the results, plot those, get rich information as well, markdowns for your documenting the code that you have been writing. A lot of that all integrated in one environment that you can easily share later on and also use for reproducing in a different environments. What is good to know about the architecture behind Jupyter is a couple of things that I want to make sure everybody understands, because this is going to be touched later on the next slides. So the notebook, you will see the browser is mostly the UI that is served from a notebook server. And then when you create a notebook, so when you started the notebook, there is a kernel that is associated and started for you as well. The kernel abstracts the execution. If you are doing, for example, Python, you will have a Python kernel. If you're doing a Scala, you will have a Scala kernel. And the relationship between the notebook and the kernel is a one-to-one. And as long as the kernel is up and running, the resources are locked for that, even though you might be just reading the notebook or might be in idle time, those resources keep connected there. So let's talk about some of the workloads that we do. So interactive workloads, usually when you're processing a lot of data, I think around this area, we also would put the scientific workloads as well. You can do data cleansing, data warehouse, start applying some machine learning, and then you can start using frameworks as Spark or Dask, for example. We heard a lot today about more going to the deep learning and AI side. Those are more resource-intensive workloads. requires kind of like acceleration hardware, like a GPU, TPUs, might be running, the training might be running for a long time. Some of the things that we do with like minutes or something might take maybe an hour or so. Some of the things that we do at our lab, it takes maybe like a couple of days. We use frameworks as TensorFlow, PyTorch, and etc. So when we talk about these and we talk about these workloads, the local development environment that we used to do and like do everything on our laptops, it's kind of like really complicated to support that on the laptops. And what we have seen these days is mostly going into kind of like building analytics platforms for kind of like you saw Collab, or like for IBM have the Watson Studio where you can go, it's hosted, or maybe you're running from your laptop, but you're consuming resources from a cluster, and then you can add support for multiple users. But when we started looking into how we will build a platform, an analytics platform, we started seeing that there was a lot of like limitations on the side of like Jupyter. Jupyter evolved from kind of like the Python console, which then started building kind of like a web browser interface on top of that. And thus, there are limitations regarding scalability, because all the kernels that I mentioned that is actually doing the execution and consuming the resources, by default, they are expected to be local. So it doesn't scale. No matter how many clusters you might, how many nodes you might have on your cluster, you will only be able to get so many kernels or data scientists supported there, because it's bounded by the limitations of the resources on one of the machines. It's also regarding security. It's a single user environment, so we have to come up with different ways to solve that. And we see here, like, no matter how many nodes, always gonna have a linear kind of like a number of supported users on that platform. And that's why we created Jupyter Enterprise Gateway, mostly to solve those problems and enable the Jupyter kind of like stack to be built and scale in a platform that can be shared among different users. So what is Jupyter Enterprise Gateway? A fancy definition is kind of like a lightweight, multi-tenant, scalable, and secure gateway that enables Jupyter Notebooks to share resources across an Apache Spark or Kubernetes cluster. For those that understand a little bit of like Jupyter, it's really kind of like an ability to do remote kernels. So we doing a kernel on the cluster, we start utilizing the resources that are available on all that cluster for us. A lot of like resources are available here. So the slide is mostly as a documentation later on, a resource for you to figure out more information. Supported kernels that we have, so like IPython, R, and Tori for Scala are kind of like the ones that we test mostly. And because we have seen that that's where most of the usage is coming. In terms of platforms, I think Spark distributed on Yarn, but also recently we also added Dask distributed on Yarn. So we started having like the analytics platforms for kind of like a business or corporations that are using Spark, and also kind of like the scientific folks that might be using Dask. We also support Kubernetes, Spark on Kubernetes, and Spectrum Conductor, which is kind of like a distribution of Spark. So what are some of the enterprise gateway features that we focused when we started looking to creating the project? So we wanted to make sure that we did optimize resource allocation. So no matter, so we want to make sure that we go across the cluster. When we spawn the kernel, so like a Python kernel for you, we can go and spawn that in different nodes of the cluster. But if you're doing like PySpark or like distributed Dask, we also want to use those for the workers and etc. Because we are doing remote kernels, we want to make sure we had end-to-end security. So we basically do all the communications between the Jupyter to the gateway and the gateway to the kernels. We do all kind of like properly secured. And we also enable multi-users. So the same user that started the notebook and requested that kernel is the one that owns the kernel, kind of like a process. In that sense, if you're running on Spark or if you're running on a cluster that has security enabled, the same security is going to apply when you, for example, try to read data from a distributed file system or etc. And we can see here that with this, with Enterprise Gateway, we then, if we need to support more users, we can add more nodes to the cluster, and that's gonna give you the support because it's adding more resources to the pool. So talking a little bit about the analytics workloads again. Let's see kind of like how it actually works in real. So when, for example, Bob comes to you and Bob comes into the environment, they say, I want a new notebook. The Jupyter server is going to connect to the gateway and say, I need a new kernel for this notebook. And in the when you have Yarn, for example, managing those resources, then you're going to start a Yarn container where, for example, for Spark, might have the Spark driver, if you're using Desk, for example, the Desk scheduler, and then we'll create other containers for the workers as well. When you have Alice coming, you will see that then a similar process happens for Alice, and you will see that like for different colors here, that basically the process that it's owned by that specific user that requested the kernel. And when you are actually executing, what's gonna happen here, so when you request this one, so when you request a kernel, Enterprise Gateway, so open a notebook with a Dask or Yarn kernel, it goes to Enterprise Gateway. Enterprise Gateway will have like a Dask scheduler with kind of like the workers there. When you execute a notebook cell, then that goes to Enterprise Gateway, which will communicate and then use all the workers to do that parallelization of the task that you have been requesting. So let's talk a little bit about kind of like the deep learning kind of workloads. When we doing deep learning workloads, there is not only the kind of like scaling requirements, but we also see that we have a lot of like different frameworks that come into place. So you might want to support TensorFlow 1x. You might start supporting TensorFlow 2x, or you might basically have like a PyTorch and different platforms. And all those frameworks, they will bring a different set of dependencies and requirements on the environment. So we need to scale, get access to accelerated hardware like GPU, but also isolate the environment. So when we started looking into that, the thing that came to mind and that was really kind of like giving us those abilities is kind of like deploying on top of like Kubernetes, which is kind of like a container, will manage a container applications for you. And we will also get those resources, such as GPU, make those as part of like the environment and enable you to associate GPUs to specific kernels, for example. When we look into the environment and we want to apply Jupyter there, we saw similar issues where if you wanted to support multiple notebooks, you have to schedule all those resources at the time that you start the Jupyter server on that pod. We applied the similar kind of like principles that we applied on the analytics platforms into Kubernetes. We decoupled the kernels, and now they started as a separate pod. And so you can associate resources just when needed, and you can give those resources back when a specific notebook is shutting down and not when kind of like the whole notebook server is shutting down. As for like what we support, Kubernetes, Spark and Kubernetes, so you can still do some of the analytics here. We are porting the Dask support to the Kubernetes environment as well. So here is kind of like a diagram of how it works. Similarly, when Bob come and requests a notebook, it talks to Enterprise Gateway. The benefit here is that you can start mixing and matching kind of like the kernel that you want with the framework that you want to use. So for example, if you want a Python kernel to do TensorFlow, you basically launch a Python kernel on a TensorFlow image. And if you do PyTorch, similarly, you can do a Python kernel on a PyTorch image, and you can multiply the number of environments that you can have. You can also have customized images that you can bring to the cluster, so you can make your own type of libraries and etc. And you can also have Spark and Kubernetes, which is managed by Kubernetes. For managing kind of like the user set, we also have integration with Jupyter Hub. Jupyter Hub enables you to start, remember like in the past we said that Jupyter Notebook is kind of like a single user environment. So Jupyter Hub enables you to bootstrap or spawn a new environment for each user. And then integrated with Enterprise Gateway, we can then have the remote kernels being started on the cluster for you. So if we look, you will see that like for each kernel that gets started, a new pod is created, and then later on when that notebook gets shut down, that resources get deallocated and that pod get terminated. So we talked a lot about the functionality. Let's start looking to some of the magic here that goes behind so we can actually get that working. So in order for you to connect your Jupyter Notebook into the gateway, there is a need for use NB2KG extension. That extension tells the notebook that you need to go to the gateway. This is only required if you're using the Jupyter Notebook 5X. When the Jupyter Notebook 6.x comes out, probably more towards middle of end of the year, that functionality is going to be incorporated in the Jupyter Notebook in itself. Also, for configuring what it means that we want to use a remote kernel. For the user, when the user starts a new kernel, you will see kind of like a drop down, and we'll have a list of kernels that are available for them. Behind the scenes, there is a JSON file that tells kind of like what needs to get started and what is the environment in that scenario. So we kind of like Enterprise Gateway brings two new components to that configuration. Kind of like process proxies that defines which resource manager you're using. So Kubernetes versus Yarn. And then kernel launcher, which is kind of like a it's kind of like a wrapper around the kernel that helps initialize and provide the configuration back to the notebook and the gateway so that you can do the connection there. What changes in terms of like configuration on your original kernel, it's basically what you see in blue here. You see that we have defined here the Kubernetes process proxy, and then we also, on the config instance, we define, for example, kind of like what image we want to use, and then at the bottom, kind of like extra configuration that we want to do when we bootstrap that environment. So here are some of the components and how you can kind of like all get play together. So in terms of front end, you can do like Jupyter, Jupyter Lab, or kind of like hosted environments. They go through NB2KG. We also have a programmatic API. So if you're just building an application or a service that you want to, let's say, leverage some functionality that is available in Spark and etc., you can start using this to kind of like emulate interactive development on the back end. We have then the kernel manager and the process proxies for each environment that we support. And then this is built on top of like extending or subclassing some of the notebook and kernel gateway code. So it's not entirely a net new thing. It's something that we have been building on top of notebook. And then here, all the supported platforms that we talked about. I mentioned already with Notebook 6.0, NB2KG is going to be directly part of the notebook. And also, if you're trying to do kind of like a programmatic API, we just have like experimental client class that can help you a lot on doing the connectivity and setting up and executing those code. So just kind of like going back in this quick summary here. So enterprise gateways will help you scale all your analytics and AI workloads. We'll use all the resources that are available on the cluster for you. We'll enable you to, like in Kubernetes, to assign GPUs, etc. Enables multi-tenant support. So in the analytics platform, so if you have security enabled, we'll do user impersonation. On Kubernetes, we will do kind of like a namespace to isolate different kernels from different users. And you can start mixing and matching all the images that you want with the kernels that you are deploying. Some of the kernels that we really test with and that supported runtimes, so Jupyter Kubernetes, Docker, Spark on Yarn, Spark on Kubernetes, Dask. Other resources, if you want to learn more, we are open source software. Everything is kind of like we are a project from Jupyter. So you can go to github.com/Jupyter/enterprise gateway. We are there. Also, like the website, documentation. If you have a question, you wanna chat with us, we are on Gitter. And we also do a lot of like blogs with announcements and kind of like articles on how integrating Gateway with Notebook and Jupyter Hub and others in the Jupyter blog. We have 2 releases going on. We call kind of like the 1X, more like a stable release. So like we have released at 1.2.0. That's what we use mostly for kind of like a lot of the products that are used there in production. On the 2.0 RC1 that we recently released, that is more kind of like all the innovation and things around Kubernetes that we are doing. And please go and take a look into how you can add that to your environment. If you like us, start us on GitHub as well. So that's pretty much it. And let me know if you have any questions. Also, I'm going to be outside later on if you need any more information. Thank you very much.
Thank you very much. That seems very useful. Does anyone have any questions for Luciano? Oh, over here, yeah.
Many thanks for your great talk. I understand the many minutes in Jupyter Enterprise Gateway, and this is the first time to listen to this kind of technology. In my company, we are not so familiar with team development for scientific issues. And my question is, how many people it gonna be the borderline which can get the merits of such environment? One, if we are not doing team development, just one person, I think we don't need any. We should not. We cannot. We don't use this kind of development system.
Thanks for your question. So I would not put in terms of like team development, but like what are the resources that you need? So for example, if you're trying to process a CSV that is a terabyte of data, you will not be able to do in your computer, and you have to scale that into a cluster or do some kind of partition or something like that. By using this, we kind of like abstract a lot of the platform and just enable you to go, for example, and access the resources of a Spark cluster, or access, in case more of like AI, GPUs and expensive resources that are available on the cluster. It's mostly, I think, going from data that fits into a laptop to data that needs multiple machines to get processed, and not so kind of like a team. It's more like the resources that are required.
So you say if we need to use huge computing resources, this tool is helpful.
That's what's going to enable that on a Jupyter stack.
Okay.
Yes.
Thank you very much.
You're welcome.
Thank you. Any more questions? So I actually have a question.
Sure.
I have two questions. The first one is there any kind of support for Slurm or any kind of HPC that is more common in a university environment rather than the Kubernetes and
So if that support is available on Jupyter, enabling Jupyter Enterprise Gateway into that, it's a very small kind of like a additional work that you need to do. Okay. So most likely if it's supported on Jupyter, it can be very easily supported on Enterprise Gateway.
I see. So I mean, I saw that actually it's essentially a wrapper around some shell scripts that are launching the jobs. Is that essentially what describes the tool?
It's actually the manage that knows how to go remotely.
Okay.
The wrapper in terms of script is how the kernels work one way or another.
Yeah.
But the additional is, so like, because Jupyter connects to a local port to talk to a kernel.
I see.
And what we do is we enable that kernel to go remotely, and then we need to handle kind of like passing the configuration back. But also if you do like interrupt to the kernel, all those kind of things which originally will go locally, we have to enable that and make that go remotely to the right kernel on the right machine, etc. That's kind of like what the gateway does.
Got it. Okay. And my next question is, I know that the IPython terminal console can connect to kernels and to Jupyter kernels. I'm wondering if this would also let you do, like, does Jupyter see this as just another kernel? And so have you ever tried to do
yeah, so for Jupyter and for the user, as the user experience, you will see no difference. We integrated in the core Jupyter kind of like to make sure that it's transparent for both when they are going remotely versus locally. So it's just, there is no difference. So if you're doing a kind of like a kernel via the UI, or if you're doing a terminal, or if you're doing the console on Jupyter Lab, which enables you to go, everything just works.
Okay. Awesome. Thanks.
Okay.
Any further questions? If not, then let's thank Luciano again.
Thank you very much.